In section 4.1, we're going to talk about exponential functions. So we've already talked about linear functions, so that's where you add or subtract, and it looks like a straight line. Now we talked about slope-intercept form, point-slope form as well, and now we're going to move into exponential functions. So an exponential function is when you multiply. So those graphs are going to look like a curve. And the format there is going to be y equals a times b to the x power. An exponential function, again, has that form, y equals a times b to the x power. I would definitely make sure that you know that, similar to slope-intercept form. A is going to represent our starting value, or our y-intercept, and then b is going to represent our rate of change. So for example, let's say we have y equals 3 times 2 to the x power. I'm going to start at 3 on the y-axis, and then I multiply by 2 each time, which is going to make that curved line there. Let's say I have y equals 1/2 to the x power. I don't see anything in front, so that means I'm multiplying by 1. So I'm going to start at 1. And then I'm multiplying by 1/2, or getting smaller each time, or like dividing by 2. So that curve's going to look like that. And to kind of further talk about that, if b is greater than 1 or our rate of change is greater than 1, we're going to be increasing and the curve's going to go up. If our b value is between 0 and 1, so like 1/2 in that example we just looked at, we're going to be decreasing and the curve's going to go down. So in example number 1, we want to know, does this table represent a linear or exponential function? Linear would mean that we'd be adding or subtracting. Exponential would be multiplying or dividing. So here we have our chart. We're going up by 1 each time. And then if I look at my y values, it looks like I subtract 2, but then I subtract 6. So can't be linear. So let's go back to the drawing board. I could also get to -3 by multiplying by 3, and then multiplying by 3 again. So that's my pattern. So this would be an exponential function. In example number 2, there are 30 deer at the North Chagrin Metro Parks. Their population doubles each month. The function f of x equals 30 times 2 to the x gives the population after x weeks. I want to know how many deer will be at the park after 5 months. So for x, I'm just going to replace with 5. So 30 times 2 to the 5th power. We're just going to use our calculators. We would get 960 deer. I want to know how many deer would there be after 1 year. So it's important to note here, 1 year is going to be 12 months. So I'll do 30 times 2 to the 12th power, and that would be 122,880 deer. In our last example, let's graph y equals 3 times 2 to the x power, and we can make an x and y chart to even kind of see our pattern here as well. If I start at 0, it'd be 3 times 2 to the 0 power, as we talked about last chapter. Anything to the 0 power is just 1. So our first point is 0, 3, which as we know is our y-intercept. At 1, we have 3 times 2 to the 1st power, which is just 3 times 2. We have 6, so that's our next point. At x equals 2, we have 3 times 2 to the 2nd power, or 3 times 2 times 2, which is 3 times 4, which is 12. So notice how the number's doubling each time, and we're getting to that kind of curve look there. If I want to go back on the graph, -1, I would have 3 times 2 to the -1. Again, we could just use our calculator for this, but that's going to end up being 3 over 2, which is 1.5. So I would go back like that. And again, notice how it's making that curve.